This question is from GATE Mechanical Engineering of 2019. This is question number 23 of set 1. The question is, water flows through a pipe with a velocity given by v vector is equal to 4 by t plus x plus y j cap meter per second, where j is the unit vector in y direction. Here it's given that t is greater than 0 and it is in seconds, and x and y are in meters. The magnitude of the total acceleration at the point x comma y, that is 1 and 1 at t is equal to 2 seconds, is in meter per second square. So we need to find the acceleration of the fluid at 1 comma 1 and at 2 seconds. So in the problem it's given that v vector is equal to 4 by t plus x plus y j cap, and this is in meter per second. Now any vector, suppose let's say v vector, the velocity vector is given by velocity in x direction into unit vector in x direction plus velocity in y direction plus velocity in z direction. Now if we compare these two equations, we will see here that only we are given vy vector. If we compare these two equations, we will see that velocity is given only in y direction, that is in the coordinate of xy, and that varies with time as well. Any function that varies with time is unsteady. So this velocity is also the velocity of an unsteady flow. Now in this problem we need to find the magnitude of total acceleration. So total acceleration can be defined as is given by dv vector by dt. Now this is also called total derivative. Total derivative. Now total, in this case it is total derivative of velocity. So total derivative can be written as the partial derivative of v with respect to time, that is also called as local derivative. In this case it is local acceleration, and plus convective acceleration, that is v vector dot del into v vector. So this is called convective derivative or convective acceleration in this case. So this acceleration is called total acceleration, or it's also called substantial acceleration or material acceleration. Okay, so this is the expression of, let's say, material acceleration. And this equation of acceleration, the material acceleration, this is also called the vector form of acceleration. So vector form of material acceleration, I can say that. Now since it is a vector form, so of course acceleration is a vector quantity. So acceleration A, that is total acceleration or material acceleration, can be written as axi cap, that is acceleration in x direction, plus ayj cap, that is acceleration in y direction, plus azk cap, that is acceleration in z direction, because we are considering here rectangular coordinate system with x, y and z axis. So we have the total acceleration at this point as well as the expression of acceleration, or generally any vector. Now we need to find the acceleration in x direction, y direction as well as z direction. So we can write acceleration in x direction as ax is given by derivative of v x with respect to time, that is local acceleration in x direction, plus vx dou vx by dou x plus vy dou vx by dou y plus vz dou vx by dou z. So this is the expression for acceleration in x direction. Now similarly let's write the acceleration in y direction. So So in y direction we can write, so velocity in y direction, derivative of velocity in y direction plus, so this is the local derivative in y direction or local acceleration in y direction. Now let's write the convective velocity. So this will be Vx dou Vy by dou x plus Vy dou Vy by dou y plus Vz dou Vy by dou z. Now this is acceleration in y direction. Now similarly let's write acceleration in z direction. So dou Vz by dou t plus Vx dou Vz by dou x plus Vy dou Vz by dou y plus Vz dou Vz by dou z. Now if we add these three terms in x, y and z direction, so if we add these three terms we will get the total acceleration. Now let's observe here, the velocity given to us is only in y direction. So the given velocity here is 4 by t plus x plus y into j cap meter per second. Now since it's only Vy we are given, there is no Vx or Vz, that means we'll assume that Vx is equal to Vz, that is equal to 0. Now this is a good time to pause the video. You can use the given values and the concept explained above. Try to find the solution by yourself. Of course you can resume the video at any time. Now let's continue with the solution. So we are given only Vy value is given, Vx and Vz is 0. So now let's substitute these values in acceleration term. Now if you see here, so Vx is already 0, so this term will become 0, the first term. Here this term will also be 0, this is 0 and this is 0 because Vx is 0. Similarly for Vz also, all the terms will be 0. That means we can see here the velocity in x and z direction is 0, so the acceleration in x and y direction here is also 0. Okay, now let's observe acceleration in y direction. So dou v y by dou t, this is not equal to 0 because the flow is unsteady, because the velocity is given as a function of time. Velocity is varying with respect to time. Okay, so dou Vy by dou t cannot be equal to 0. Now Vx, we already know it's 0, so this complete term will become 0. Now Vy is not 0 because it's given here, and that's why dou Vy by dou y is also not 0 because Vy is also function of y, right? Now Vz is also given 0, so this term will become 0. Okay, so now we have the expression of acceleration in y direction, and that can be written as Ay is equal to, let's see what we have got here. So we have dou Vy by dou t, let's write here dou Vy by dou t plus, what else we have? So all terms are 0 other than this. So Vy dou Vy by Vy dou Vy by dou y. So also you can observe here from the expression of acceleration, we see here that Ax we have got is 0, we got only Ay, and Az is also equal to 0. So total acceleration A vector is equal to Ay j cap. J cap already we have written here. So now let's substitute the value of velocity in this Ay, that means acceleration, and perform the operations. So dou by dou t of velocity given to us is 4 by t x plus y plus, now Vy is 4 by t x plus y multiplied by, so let me multiply it by here, dou by dou y of 4 by t plus x plus y. Okay, so this we will get, so here x and y will be equal to 0, I mean derivative of x and y with respect to time will be equal to 0. Derivative 1 by t, derivative is minus 1 by t square, right, plus of course this I forgot to put, this is j cap. So this complete is j cap plus now 4 by t plus x plus y. Now here derivative of x and t with respect to y will be equal to 0. So here derivative of y with respect to y will be equal to 1. So let's just multiply it by 1, and this is in z direction. So this is the expression for total acceleration or total acceleration vector. Now we need to find the acceleration at x is equal to 1, y is equal to 1, and t is equal to 2. So at this point and this moment we need to find the acceleration. So let's just substitute the value here. So we will get here 4 by minus 4 by t square, t is 2, so this will be 2 square is 4, plus 4 by t, t value is 2, plus x is 1 and y is also 1 j cap. So here this will be minus 1 and this will be 2. So 2 plus 1 plus 1 4 minus 1 is 3. So 3 j cap. So acceleration vector we are getting is 3 j cap. Okay. And of course it is in meter per second square. Now for any vector it's given by, in this case acceleration vector is given by its magnitude and its direction. So the direction is unit vector of that vector. So any vector, in this case acceleration vector can be written as the product of its magnitude and its direction. Now if we compare these two equations, if we compare this and this equation, we will say that magnitude of a vector, that is a vector mod, is 3 meter per second square. Now let's go back to our question. So the magnitude of the total acceleration at the point x comma y is equal to 1 comma 1 and at t is equal to 2 seconds is 3 meter per second square. Now to get more information on fluid kinematics such as acceleration, velocity, streamline, streaks line and potential lines, you can follow the NPTEL course on Introduction to Fluid Mechanics and Fluid Engineering by Professor Suman Chakravarti of the Department of Mechanical Engineering, IIT Kharagpur. Hopefully I was able to solve your doubt. Have a great day.